In this video, we're going to look at the oxidation reaction in organic chemistry. In particular, we want to look at the oxidation of alcohols. Let's jump right in. In organic chemistry, an oxidation usually means making more carbon-oxygen bonds on my molecule. So it's easier, actually, than what we learned in general chemistry. So let's take a look at some simple alcohols. This alcohol has one carbon-oxygen bond, and let's make it a primary alcohol. That means the carbon with the OH only has one other carbon atom attached. If we oxidize this compound, oxidations often here means we lose two hydrogen atoms. So if I lost one hydrogen atom, two hydrogen atoms, if those two hydrogen atoms fell off, we would go from one carbon-oxygen bond to two carbon-oxygen bonds and make an aldehyde. So this is an alcohol. This is an aldehyde. Now notice we just pulled off these two hydrogen atoms. So the methyl's still on there, the hydrogen's still on there, and we made a carbonyl. And we'll soon learn that aldehydes can further be oxidized with strong oxidizing reagents. In the carbon-hydrogen bond of an aldehyde, we can stick an extra oxygen in there. So when we oxidize it, we'll go from two carbon-oxygen bonds to three carbon-oxygen bonds. So now, instead of an aldehyde, we have an extra oxygen in there, and we have three carbon-oxygen bonds. So we went from 1 to 2 to 3 carbon-oxygen bonds. Another oxidation. And this, of course, is a carboxylic acid. The opposite direction is called a reduction. And we've seen those in another video where we add things like sodium borohydride or lithium aluminum hydride can reduce our alcohol or carboxylic acids to alcohols. All right, that's what an oxidation looks like for a primary alcohol. Let's do an oxidation sequence for an alcohol that's a secondary carbon. So that means it has two carbon atoms attached to the alcohol carbon. These could be whatever. We'll make them methyls. So 1, 2, 3, this must also have a hydrogen atom attached. So this is a secondary alcohol. If I oxidize this, well, the first step is we lose two hydrogen atoms. So we lose this one from the alcohol and this one from this carbon. So that means we'll make a C double bond O. This methyl still attached. This methyl still attached. These two hydrogens have been pulled off, and we make this ketone. Now we saw that aldehydes, this carbon-hydrogen bond can be opened up and another oxygen atom put in to further oxidize an aldehyde. But for a ketone, carbon-carbon bonds are just too strong. So I can't squeeze another oxygen in, so we'll stop right there at the ketone. We can't go on and oxidize it any further. Let's take a look at one more alcohol, a tertiary alcohol. So my alcohol, if it's tertiary, that means there's three carbon atoms attached to this. If I try to oxidize this with something, some reagent, we need to pull off our two hydrogens. Well, here's one hydrogen, but this carbon atom does not have a hydrogen on it to pull off to make my C double bond O carbonyl. So this reaction must not work. I can't oxidize tertiary alcohols. Now notice, we don't need to memorize something. Let's see, primary alcohols go to aldehydes and secondary alcohols do this, and maybe we make a boson, and tertiary alcohols don't oxidize at all. Once we understand the first step is pulling off two hydrogens, we can see that this just won't work. And we can see that this one works, but a hydrogen and a carbon will be on there. And then just let that key in when you see an aldehyde. Oh, if it's strong enough, I can keep going and insert one more oxygen. Or a secondary one. Pull off your 2 hydrogens, keep your groups on there, and see, oh, there's not an aldehyde. I must stop here. You don't have to memorize anything. Just make sure that makes sense to you. Let's look at oxidizing reagents. There are all kinds of oxidizing reagents. There are many kinds of oxidizers. We'll just look at some of the most common ones that you'll encounter in sophomore organic chemistry. One is sodium dichromate with sulfuric acid. So this is sodium dichromate. And what I want you to see is there are 7 oxygens in here. If somebody wrote this down and you saw all of those oxygens, you should think oxidizing agent. So this is a very strong oxidizing agent. It's a very good one. And you might see others. These 2, sodium dichromate and acid, make something called chromic acid. So some people will just write chromic acid. Others might write sodium dichromate and acid. That's a strong one. So that means if I go back to my original reactions, if I use a strong oxidizer like sodium dichromate and sulfuric acid, that would oxidize from my alcohol to my aldehyde, and it would just keep going. So they would do this reaction, make this, and it would just keep going. And I would end up with this carboxylic acid because it's so strong I can't stop. It goes all the way. If I used sodium dichromate here and sulfuric acid, well, it's good enough. It's a very strong oxidizer. It can oxidize to here, but it can't keep going because ketones are where I stop. And sodium dichromate would not be able to touch this tertiary alcohol because there's not 2 hydrogens to pull off. So in your head, I would just learn this one as the strong one, and it takes your alcohols as far as they can go whenever we look at our oxidizing reactions. But let's say I wanted to take this reaction, and instead of going all the way from here through the aldehyde all the way to the carboxylic acid, what if I just wanted to do this? Oxidize a little bit, but stop at the aldehyde. Well, I need a weaker oxidizing reagent. So if I want to stop here at the aldehyde and not keep going, there are oxidizing reagents that do that. Let's come back to this sheet. So this is the strong oxidizing reagent. Weak oxidizers, I think maybe there's 3 of them I would learn. The most common one I would use, I don't know if it's the most common, but the first one I would learn is called PCC. We won't worry about what it stands for. It stands for pyridinium chlorochromate, but who really cares? If you remember PCC, this is a weak oxidizer and will stop at the aldehyde. It can also do the reaction to the ketone, and of course would stop at the ketone. But this is not strong enough to insert and make that carboxylic acid. There's 2 other reagents that are just like PCC. One is called a Swern oxidation. And I would just memorize the name Swern oxidation. So you might have that. Or DMP is another one. Those are 3. I would say PCC or Swern are probably the most common ones, the ones I would memorize first. So let's just take a quick look one more time. Just do a couple reactions. Let's take one butanol, and let's use sodium dichromate and sulfuric acid. What does that make? Well, we don't have to have the whole thing memorized, but let's just take it one step at a time. Let's see, is this one weak or strong? That's strong. So let's take it as far as we can take it. The first step is to remove 2 hydrogens. So I have this hydrogen on one side and I have this propyl on the other. I see this is an aldehyde. Okay, I can remember that if it's strong, I can insert in there and go from 1 carbon-oxygen bond to 2 to 3. It will keep going to this compound. What if I take this and react it with PCC? Well, it does the first step to make an aldehyde, but PCC, that's the weak one if I remember right. So I can't do that step and insert, so I stop here at the aldehyde. Let's pick another molecule. So let's take cyclopentanol, and let's go with sodium dichromate and sulfuric acid. First step, remove 2 hydrogens. There's one, and there's one on this carbon. So that would make a C double bond O from 1 carbon-oxygen bond to 2. And that would make this. Can I keep going? Let's see. Carbon atom, that's a strong bond. That's a strong bond. Nope, I can't keep going to a carboxylic acid. I'll stop right here at cyclopentanone. Well, what if we use a weak one like PCC? Well, it can also do that first step to make this. And if it's weak, it can't go any further. So I get the same product if I use PCC. Let's look at one more. Let's take a strong oxidizer like this. What do I get? Well, this is a trick question that they'll throw at you sometimes. This carbon, this alcohol, has 3 carbon atoms attached. It's tertiary. So what would be the 2 hydrogens I'd pull off? This one and, oh, there's no hydrogen on this carbon. This can't work. So I would just stay right here. That reaction can't proceed. No matter if I use PCC or SWERN, the weak ones or a strong one, I can't keep going. So that's just a quick review on what you need to know about oxidations of alcohols. The first step, lose 2 hydrogens. If you have an aldehyde, if it's strong like sodium dichromate, keep going to the carboxylic acid. Go from 1 to 2 to 3 carbon-oxygen bonds. If it's a secondary alcohol, you remove the 2 hydrogens and you get a carbonyl with 2 carbons. Those are too strong to keep going. In tertiary alcohols, you'll recognize there's not the 2 hydrogens to pull off. You can't oxidize. Those are the tricks for how to oxidize alcohols to carbonyl compounds. Hey, I hope that's helpful. If you'd like to watch more of my organic chemistry videos, be sure to subscribe to the channel, click on some of the other links, and go back and learn all about alcohols or other topics in organic chemistry.